All right, good morning, geometry students. Today we are going to talk about the Pythagorean theorem. You maybe did this last year in Algebra 1, you maybe didn't. I'm not sure where you ended. So there's nothing to print off, just get some paper ready and we are going to begin. Okay, so the Pythagorean theorem is a theorem that is applied to right triangles only. It is used to find a missing side on a right triangle. So just a quick review of right triangles. The two sides that connect to the right angle, those are called the legs. And in the Pythagorean theorem, they are typically referred to as variables A and B. And it doesn't matter which you put for the A and which you put for the B, they can be swapped. They just have to be on the legs. All right, and then the hypotenuse is always the side across from the right angle, and it's always labeled as C in the Pythagorean theorem. All right, so I'm going to say what it is, and then we'll look at the formula. All right, so Pythagorean theorem is the sum of the squares of the legs of a right triangle equals the square of the hypotenuse. Whew. The sum of the squares of the legs of a right triangle equals the square of the hypotenuse. All right, so what does it mean to square the legs of a right triangle? So what I have drawn here is a right triangle that is a standard, very common, one of the most basic right triangles. People just usually remember 3, 4, 5 are the sides of a right triangle. So to square a side means that I take its length, which is 3, and I square it. And I visually just squared it by making a square off to the side there. And it would be a 3 by 3 square, clearly. And if I divided it into all of its little components, there are 9 little squares, right? 3 by 3, 3 times 3 is 9 little squares. All right. Now I do the same to the other side. It would be a 4 by 4, making it an area of 16 or 16 little squares. So that is what I just did was the squares of the legs. Now I'm going to do the sum of the squares of the legs. That means to add the 9 and the 16 together. 9 and 16 together equals 25. 25. So the question is, can you make a square out of 25 little squares? And it just so happens you can, because it's a perfect square, 25 is. So I could make a square out of these 25 squares. So you can see that you could cut these apart and put them together in any kind of order, but this was just the easiest way to do it digitally. The 9 squares from the 3 side are in the middle, and then I just kind of outlined it with these 16 green squares to make a big square that's 25 by 25. And that's what it means, that the sum of the squares of the legs equals the square of the hypotenuse, right? 25 is the square of the hypotenuse. So what we did is we took the sides 3, 4, and 5, and we applied the concept of just squaring all the sides together, squaring all the sides. So we squared the 2 legs, added them together, and that equals the square of the hypotenuse. This relationship is true for all right triangles, and it gives us a way to find a missing side on a triangle such as this one. Okay, I'm going to switch over to the document camera, and we're going to figure out what this missing side is by squaring the 2 sides and adding them together. Okay, so before we solve that triangle problem that was on the smartboard screen, let's just actually write the Pythagorean theorem. So here's our right triangle. The legs are A and B, and they can be swapped, but the hypotenuse always has to be the C. And so the official Pythagorean theorem says that you can square the legs and add them together, a squared plus b squared, and that equals c squared. Okay, so let's go ahead and work that problem that was on the smartboard. I'm going to scooch this down. Let's see, I don't have that sitting right in front of me, but I believe it was 5, 12, and question mark. Okay, so we are going to go ahead and label the two legs with A and B, and the question mark is on the hypotenuse, so it has to be the C. And then all we're going to do is substitute our numbers into the Pythagorean theorem. All right, and then we solve it. Okay, so this left-hand side, you have to square these first, right? No square rooting. That's not the square root method. We never, on our square root method, just took square roots of a bunch of individual things. We had to get one side to equal just our variable squared, and the other side was just equal to a number. Square root both sides. Okay, so 13 equals C. And if you remember, when we were doing just pure algebra, we always had to have two answers, 13 or negative 13. Now, in geometry, sometimes we reject the negative answer because that would be saying that this length of the side of the right triangle could be negative 13, which it cannot. So even though mathematically it exists, we're going to reject it a lot of times in geometry because of the nature of the questions, because we're always kind of finding side lengths or angle sizes, and we can't have negatives of those. All right, so there's the missing side. Okay, so moving on, let's work another one. We'll call this example 2. All right, here's a right triangle and a different rotation. Put the right angle right there. Okay, so we have an 8 here, a 16 here, and this is the missing side we're trying to find. All right, so this is the hypotenuse. 16 is the hypotenuse, so we know that has to be the C. And the other two sides are just A and B in any order. All right, so if I run them through Pythagorean theorem, I'm going to have A squared plus 8 squared equals 16 squared. All right, now square everything first. No square rooting yet. It's way too soon for that. Okay, and now we need to isolate the squared term so we can use our square root method. So I'm going to subtract 64 to 192. Now I can take the square root of both sides. All right, and square root of 192, I'm going to have to do a little bit of work for that. So I'll go off to the side and do my factor tree. 192, I know is divisible by 2, so that's 2 and 96. All right, 96 can go by 2 again. 2 and 48. 48 is one. It's small enough now that I have worked with it a bunch, so I think of that one as 16 times 3. And I like that combination because 16 is a big perfect square. Okay, so I have to use all the tree ends, right? 2 times 2 times. I'm just going to keep 16 as 16. It already is a perfect square. But, so these just multiply to make 192. I'm going to turn that into a 4 times 16 times 3. 4 times 16. I'm going to turn that into 64 times 3. So here's a good breakdown. 64 times 3, which is 8 root 3, right? And just kind of always keeping in mind that if it were pure algebra, we would also have the negative option, but because we are simply finding a side on a triangle that cannot be negative, we just keep it as positive 8 root 3. Okay, another example. Example 3. right triangle. This side will be square root of 10. This side will be 12. And we're going to find that side. All right, so this is the hypotenuse. That's my C. I'll just make this side A and this side B. Okay, so we're doing A squared plus B squared equals C squared. Okay, and we need to square the square root of 10. So, I mean, you could look at it two ways. Squaring and square roots are inverse operations, right? What the square root does to the 10, the square comes along and undoes. So they kind of just whoop, cancel each other out, and all you have left is the 10. You know, another way to look at it is if you're going to square the square root of 10, that means to take the square root of 10 and times it by itself, which is the square root of 100, which is simply just 10. 144. All right. Now we'll go ahead and get the b squared all alone. Before I do any square rooting, let's see, 134. Okay, 134. Let's see, I'll go to this side. 134. I know it's divisible by 2. 67. And I think 67 is prime, right? It's not divisible by 2 or 3 or 6 or 7 or 5 or 4 or 8 or 9, 10. Which means 134 is the answer. And just keep it positive since we're dealing with triangles. Okay. Okay, example 4. So here's my right triangle. One leg is 12, one leg is x plus 5, and the hypotenuse is 15. All right, this one is just a little bit more complicated. So we're still going to think about, you know, our A is a leg, B is a leg, C is the hypotenuse for plugging into our formula. Okay, so we have 12 squared plus x plus 5 squared, right? The whole side is being squared equals 15 squared. And we reviewed our two methods for solving quadratics. This right here is a quadratic. Actually, all of these Pythagorean theorem ones are quadratics. But there's a couple different ways to do this, and I'm going to go ahead and keep it like this. I'm not going to do anything with the x plus 5 at first. I'm going to go ahead and just square the 12 and square the 15. And now, let's go ahead and minus 144 over to the right-hand side. 181. And now I'm just going to use square root method. Square root of both sides. X plus 5 equals positive or negative 9. So we are going to go ahead and try to figure out both answers first and make sure that we choose the correct answer for this problem. And maybe sometimes they both work. Sometimes the way they're set up, they just both work. So we're going to do x plus 5 equals positive 9 or negative 9. All right, so x equals 4 or x equals negative 14. Okay, so when you think about what can x equal, if x is equal to 4, then this side becomes 9, which seems legitimate. If x is equal to negative 14, then this side all of a sudden becomes a negative 9, and that's no good. So we're going to reject our negative, and only circle the answer that works. All right, so that is the last example. The assignment tonight is a worksheet, I believe, and so just make sure that you show your work and